In this lesson, we will study how to find out the equation of lines which are parallel to the x-axis or the y-axis. Before we figure out how to find out the equation of these lines, we need to first know that if the examiner says that the lines are parallel to the y-axis, there is one more way to say it: lines perpendicular to the x-axis. Now, let me explain this concept. These lines are basically parallel to the y-axis and I can see it clearly. At the same time, these lines are also perpendicular to the x-axis. We can even see this as well. So, these two statements makes the same sense. You can say it in any way you like. Now, the way you have to find the equation is by this: x equal to a. Now, what exactly is this a, and how would you know what value you need to put in place of this a? It's really simple. The main key concept is, if you see that the line is parallel to the y-axis, you just need to see from where exactly that line is crossing the x-axis. So if you see that the line is crossing the x-axis at this point, this is my value of a. You just need to count 1, 2, 3, 4, 5. So this is 5. So the equation will be x equal to 5. So my value of a turns out to be 5. X equal to 5. Now you just need to count 1 and 2. So this is basically 2. So it will be x equal to 2. Right? On the other side, if you go on the left side, so this is basically negative 2. So your equation turns out to be x equal to negative 2. If you move further, so you get negative 4. So this equation turns out to be x equal to negative 4. So the idea is really simple. If you see the lines are parallel to the y-axis, so obviously they will be perfectly vertical. And if a line is vertical, obviously it will cross x-axis. So the equation will always be in the form x equal to some value. Because the lines are vertical, they will cross the x-axis at a certain point. So you will write x equal to some value, and that some value will be the point at which the line is crossing the x-axis. Simple. Now, this same concept will be applied on one more case in which the lines are basically parallel to the x-axis. Now, likewise, you can even say this as lines perpendicular to the y-axis. So I can clearly see that these lines are parallel to the x-axis, but we can also see that these lines are also perpendicular to the y-axis. That gives us this conclusion that these two statements makes the same sense. Now, how to find out the equation of these lines? The idea remains the same. Because these lines are parallel to the x-axis, so these lines are perfectly horizontal. So obviously, if a line is perfectly horizontal, it will cross y-axis at a certain point. That's the reason the equation of these lines will be equal to y equal to some value. And this some value will be the point at which these lines are basically crossing the y-axis. So this is my value of p. You just need to count. So 1, 2, 3, 4. So this is 4. That means the equation turns out to be y equal to 4. So this is y equal to 4. My value of b turns out to be 4. So this is 2. So your equation turns out to be y equal to 2. If you move on the downside, so this is y equal to negative 2. You just need to count. So it is just this simple. You just need to count, and this will be y equal to negative 3. So this is how you basically find out the equations in this case. The last concept of this lesson is the slope concept of parallel lines and perpendicular lines. So the concept is really simple. All you have to do is just keep in mind that parallel lines are the lines which always have a certain same distance and they never meet each other. The distance is always the same, and this is why they never meet. And this is the only reason they have the same slope. So the slope of line M1 and the slope of line M2 will be equal to each other. On the other hand, if you have perpendicular lines, so the perpendicular lines have the angle of 90 degrees between each other, and the slope condition is given as m1 times m2 is equal to -1. Their product is basically equal to -1, and you can even write it down as m1 is equal to -1 over m2, or you can even write it down as m2 is equal to -1 over m1, and this is why it is also called negative reciprocals of each other.